Okay, here are the notes for 9.3 on hyperbolas. Let's get started. The first one is just a review of sketching a hyperbola. So we need to first look at the equation to understand the orientation. Because our x squared is listed first, that means our hyperbola is going to open to the right and to the left. If it had a y squared first, then it would open up and down. Now we need to determine our h and our k. My h is right here, my k is there. So that tells me my center is at 3, -4. So I'm going to go to 3, -4. And I'm going to put a point right there. I'm going to go fairly fast through this because it is a review from last year. And then we look at the numbers underneath in the denominators. So this 16, we need to take the square root, and that's going to be our a value, and a is equal to 4. So that means from the x, we're going to go parallel to the x-axis, right or left, 4 spots. 1, 2, 3, 4. And that's going to be one of our vertices. And if we go to the left, 1, 2, 3, 4, there's our other vertice. And I'm just going to mark these with a little V. Now what the 9 does is it allows us to be able to figure out our asymptotes. So this is our b value. It's going to be the square root of 9, and that's 3. So from our center, we're going to go up 3, and we're going to just make a little line here. And going to go down 3. Okay. Now where our vertices are, we can actually close this, and sometimes this is called the box method. It's whatever way you want to find it. Because where our corners of our rectangle that we've formed, that's where our asymptotes go through. So I'm going to sketch our asymptotes. There's the first one. There's the second one. And now we just have to sketch our hyperbola. Our hyperbola needs to hug our asymptotes and go through our vertex. So I'm going to come in on the left side, I'm going to go really close, hit the vertex, and then come back out. And do the same on the right. Okay. You want to make sure that your hyperbola is close to your asymptotes. If you do it kind of way out here, that's not going to be right, so don't do that. Okay, that's example 1. Let's move on to example 2. Okay, so now example 2, we are going to put it in standard form, and then we have to identify some information. So I've already started by making a graph. So pause this for a second while you make your graph in your notes. Okay, so you should have made your graph. Now to get this into standard form, what we're going to do is we're going to complete the square. And we've been completing the square quite a bit in this unit, so this should be fairly quick. But I do want to do this one with you because the fact there is a little area that students tend to struggle with. So I'm just going to complete the square over here to the side. And where they struggle is because one of our x squareds is negative. And so we have to remember to pull that negative. Okay, so now complete the square. I'm going to rearrange and put my y's and my x's together. And I'm going to put the positive y squared first because I know that the first part of my equation has a positive squared term. Minus the x squared. And I'm going to move that 47 just to the other side. Pull out the 16. Divide the 4 by 2 and square it, and you get 4. Here, I'm going to pull out that negative because our x squared needs to be a positive. Because inside of parentheses, it's a positive x. So, and that's going to change that positive 2 to a negative 2. Divide by 2 squared gives me a 1 plus, and I did not give myself enough room here. So it's negative 47 plus 16 times 4 is 64. And then I have the negative times the 1, so I'm going to have minus 1. Now let's just finish it up. (16y) plus 2, the quantity squared, minus x minus 1, the quantity squared, equals, now the negative 47, the 64, and the negative 1 are all going to add to be 16. Divide by 16. And there's our final equation. Okay. So now what I'd like you to do is I'd like you to sketch your graph. We just did this in the previous problem, so pause the video, sketch it, and then come back and let's see how you did. Okay. So this is what your graph should look like. Please note that your hyperbolas are opening up and down because the y squared's first. And underneath that y squared, hopefully you remember to put a 1. Okay? So now let's find our information. Well, we already know our center. Our center is at 1, negative 2. We can find our vertices by looking where our hyperbolas are. So they're above and below, so it went up and went down by 1. So it's at 1, negative 1, and 1, negative 3. The foci is a little bit harder to find. So to find the foci, involves a little bit of calculations. The foci is our c distance above and below our center. Well, if I know c squared is equal to a squared plus b squared, that gives me c squared is equal to 1 plus 16. So c is equal to the square root of 17. Can't simplify it, leave it alone. Now you're probably thinking, well, how do I do the square root of 17? If you look at our center and our vertices, all the x values are still the same. They're still going to be the same with our foci. So it's going to be 1, and it's going to be above and below our y value. So our y value from our center is negative 2, so to go above, we would add the square root of 17. And to go below, we would subtract the square root of 17. Or you could rewrite it as this 1 comma negative 2 plus minus square root of 17. That is also acceptable. The last thing we need is our asymptotes. And the asymptotes are really easy to find because we're looking for equations of lines. We're going to use point slope. And we get our point slope from our numerators of our in our fractions from our equation. So the y plus 2 equals, and then we have our x minus 1. The only thing we're missing is our slope. And if we look at our equations that we graphed, we went up 1 over 4. So the 1 came from our y value, from the denominator of our y, and the 4 came from the denominator of our x. So we can always just go back to our original equation, take our numerators, and then we're going to use the plus or minus the square root of the number under the y, and that's 1, and the square root of the number under the x, which is 4. And that's the equation of our asymptotes. Okay, let's move on to the next one. Okay, so this time we're going to find the equation in standard form of a hyperbola given some certain information. In this case, we're given the vertices and the foci. So the first thing I want you to do is I want you to pause the video and I want you to plot the points and determine which direction your hyperbola is opening. Is it opening to the right or left, or is it opening up or down? Okay, so you should have plotted the points, and you notice that the foci are to the right or the left of the vertices. Remembering that the foci are inside your hyperbolas, that means my hyperbolas are opening this way. And I'm just going to kind of sketch them here. And all this is doing is helping us determine which equation we have. Okay, so now that tells me, since my parabolas are open to the right or left, that I have an x squared. So an x minus h, the quantity squared, over a squared, minus y minus k squared over b squared equals 1. Now I just have to fill in the blanks. I need to find h, k, a, and b. Well, to get the center is going to be right in the middle between my foci. So this has a distance of 4, so right in the middle is right here. So my center is right there. And that points 1, 2, 3, 4, 1, 2, 3. That points at 4, 3. So there's my HK. So I'm going to fill in that. Now I need to find A and B. Now if you remember your vertices, the distance from your center to your vertice is your A value. So that means this distance right here is 2. Well, that's my A. So that's 2 squared. Now I just got to find B. And this is where our foci come in. To find our foci, remember, is C squared equals A squared plus B squared. Well, I know my A squared, and that is 2 squared. I'm looking for B. Now I need to find C. C is the distance from our center to our foci. And that's this distance right here, and that is 3. So I now have 3 squared here. And I'm just going to solve for B squared. So I have 9 equals 4 squared, or 4 plus B squared. So B squared equals 5. I don't even have to square root it, because in my equation I need B squared. So I'm just going to put the 5 right here. Now I just got to clean it up. I have x minus 4 squared over 4 minus y minus 3 squared over 5 equals 1. Okay, that's example 3. Let's move on to the next one. Okay, so now we're on to our word problem. Please make sure you read the full word problem before we begin. So please stop the video to do that at this time. Okay, so we have 2 radio transmitters that are 250 miles apart. I'm just going to highlight a few things to help me out here. I'm actually going to change this a little bit. There we go. So they're 250 miles apart. The signal is sent simultaneously from each transmitter. Okay. Transmitter 2 receives it 500 milliseconds after it receives from T1, the transmitter 1. That's kind of important. That tells you how far away transmitter 2 is in comparison to transmitter 1 at 0.876 miles per second. So to find the equation of the hyperbola with the foci at T1 and T2 on which the ship is located. So I'm going to do my work off to the side here. First thing I need to know is what is how much further is the distance from T1 or from T2 than it is from T1. So I'm going to take the 500 milliseconds times the 0.186, and I'm going to rewrite this so it's a little bit neater. And that gives me 93 miles. Okay. Now remember, a hyperbola, the foci, at the very beginning it says that it's the set of all points where the difference between the distances of the foci is constant. So it doesn't matter where the ship moved, we would always get this 93 because the difference of them. Okay. So another cool thing is the fact that this difference is also R2A. Okay? So that tells me, if I divide that by 2, that 46.5 is my A value. I already know where my center is because I'm going to make the assumption that if we look at our picture here, our hyperbolas are going in this direction here. They're going like this. So I'm going to, for just ease of ability, I am going to put my center at 0, 0. So I'm going to put HK at 0, 0. I know A. I just need to find B. And so we're going to use our foci to find B. Because I know that C squared equals A squared plus B squared. C squared is the distance from, I'm going to look at my picture again, from my center to one of the transmitters. That's this distance right here. And that's 125. Let me kind of clean that up a little bit. It's a little hard to read. So C squared is going to be 125 equals 46.5 squared plus B squared. Okay. So do your arithmetic and find your B value. So pause it and then come back and let's make sure our values match. Okay, you should have got that B squared is 116.029. Now let's just write our equation. X squared over, and the reason I know x squared is first is because my parabolas are opening to the right or left. The 2162.25, my A squared value, minus my Y squared, and that B squared that I just solved, which was 116.029, equals 1. Okay, so there's the equation of the hyperbola with the foci at T1 and T2, which the ship is located. So that's part A. Let's go on to part B. Part B says that if the ship is 100 miles east of the x-axis, determine its distance from the coastline. So let's go back to our graph. So it's telling me that my ship, I'm going back to my picture, that my ship from here to here, that this is 100 miles. Well, that's, if you look, that means it's also this distance right here. So we're 100, so our x value is 100. So I'm going to put 100 in for x into our equation. So I'm going to get 100 squared over 2162.25 minus y squared over 13,462.75 Hold on, let me look at this again. What did I do wrong? Oh, back in the other equation. I am sorry. I gave you b here. This is b. B squared. I looked at it wrong. Sorry about that. This is actually supposed to be 13,462.75. I gave you the b as 116.02, and I should have given you b squared. I'm sorry about that. All right, so now we have that in our equation here, equals 1. Now we just got to solve for y squared. So pull out your graphing calculator, and let's do 100 squared divided by 2162.65, and then take away 1. And you should get about 4.6248. Now we don't want to, we want to keep that number on our calculator. We're not going to round it. And we still have y squared over 13,462.75 equals 1. Now move that 4.6248 to the other side, and I get negative y squared over the 13,462.75 equals, so 1 minus my answer, negative 3.6248, 3.6248. Multiply both sides by 13,462.75. And I get negative y squared equals negative 48,799.9393. Move our negatives, and then we square root. And we get that y is equal to 220.9071. So our ship is 220.9071 miles from the coastline. Okay, that's the last of the notes for chapter 9. Or 9.3, I'm sorry, not for the whole chapter. We've still got another section after this. If you have any questions, make sure you come to class.